Okay, I'm going to go over tonight's homework, and it's numbers 1 and 2 on this side. The directions for the top says, or for all of it, says express each relation as a table, as a graph, and as a mapping diagram. Okay, so we've got this set of ordered pairs. So we have 1, 2, 3, 4, 5, 5 ordered pairs. So we're going to write x and y. That you should always start your table with x and y, or whatever variables are given to you. In this case, for now, we'll just use x and y. Then this is your x and this is your y. Remember, x always comes first and then the y. So -2, -4. And then -1, -1. Then 0, 0. Then 1, -1. And then 2, -4. Okay, so great. We took this set of ordered pairs and this relation, and we represented it, expressed it as a table. Now we're going to take the same ordered pairs and then express it as a graph. So be very careful about your numbers here. This is your x-axis. I'm going to make that a little darker, x and y. So start at the origin, -2, -4. I go -2 on the x, and then I go down 4. 1, 2, 3, 4. That takes care of that one. And then I want to go left on the x-axis and down 1. So left and then down 1. Then we got 1 at 0, 0 at the origin. Great. And then 1, x is 1, then -1, so over here. And then 2, -4. Interesting. Looks like there's a pattern, doesn't there? But doesn't mean it's a function. We have to find out. So I'm going to go ahead and go to the domain, remember, or the mapping. Remember, all x values go here and all y values, and remember there's no repeating here. Okay, so for example, let's look at the x's. So I want to put -2, -1, 0, 1, and 2. All of them are going to be written because there are no repeating. Okay, so 1 and then 2. And then let's go to the y values. So we've got these y values. And looks like we have a couple of them that are repeating. We've got a -4 and then a -1. So no repeating yet, 0. And then we have another -1, which we already wrote, and another -4, which we already wrote, so we're not going to write it again. The arrows will show us that they were used again. So let's go back here. -2, -4, these pair together. And don't forget to draw your arrowhead. -1 pairs to -1. 0 pairs to 0, 1 pairs to -1, there you go, and then 2 pairs to -4. Okay, done with the mapping diagram. Domain is all the x values. Again, this one's also domain and range. You don't have any repeating. Okay, so set value, set notation. Literally, you can pull from here since we already had a mapping diagram. Or if you, let's say you didn't have that, you would come back to your original set of ordered pairs and you would write -2 as your x value, then a -1, then the 0, then the 1, and the 2. And none of them repeat, so we write every single one of those. Let's go to the range. If you want, we already wrote the range here, basically, and there are no repeaters, so we could just say, oh, -4, -1, and 0, which if you didn't have this, you can go back here and it's true. You write -4 for the y, -1, then your 0, and then the -1 and -4 have already been used. So you have 3 numbers here, whereas you have 5 numbers here, which makes sense, okay? So the question now is this a function? So let's see, okay? A couple of ways to tell. Look just right here, there are no repeating x values, so yeah, it's a function. Another way to tell is, if you draw a vertical line here, check, vertical line, it passes the vertical line test. Okay, so you have a couple of ways you can answer this. You can say, for sure it's yes. Okay, and then you can write it one of 2 ways. Because there are no repeating x values. Or because the relation passes the what? Vertical line test. Okay, that's number 1. Now let's go to number 2. Now, we're going to write the table here, x and y, and we've got 2, 1, then we got 2 and 1/2, then we got 2, 2, then we got 2 again, and then 2.5. Looks like we only have 1, 2, 3, 4 points. 1, 2, 3, 4. It's always good to check, so this one doesn't get used. Okay, so interestingly, you can write, if you go to 1/2, you put that in your calculator, but 1 divided by 2, that's going to be 0.5. Okay, decimals always help when we're graphing. And then this here, you have a 2.5, so that this one ends up being 2.5. Okay, so let's go over here. We've got, this is our x-axis, this is our y-axis. So I'm going to do 2 comma 1, so I have to go positive 2 to the right and then up 1. Okay, that takes care of that. And then 2 and go up 1/2. So I go 2 to the right and I only go up 1/2. And then I go 2 to the right and up 2 right here. And then 2 to the right and then up 2.5. 2.5. Interesting. So let's see what that looks like. Okay, so let's see. I've got in the x values, I have all repeating and they're all 2s. So I'm just going to write 2 once. Okay, these are my x values and these are my y. Now let's look at the y values. You have a 1, a 1/2, 2, and a 2.5. Okay, none of them are the same. So 1, a 1/2, 2, and a 2.5. Now you got to draw your arrows to show the pairing. So 2 gets paired with 1. 2 also gets paired with 1/2. 2 gets paired with 2. And 2 gets paired with 2.5. And that completes my mapping diagram. So if I want to pull from here, I can say for the domain, all the x values of this relation, well, all of them is just 2, so you just write 2. And that's your domain. The range here, all of them are different, so you write 1, then 1/2, 2, and then 2.5. And is this a function? No, because, okay, and you can write 2 things. All the x, or I think better way to say it, see, even me, I have to think through what I'm saying, so I'm going to wipe that out, and I would say because there are repeating x values. Alright, versus, or you can say no, because the relation fails the vertical line test. Well, let's see what that means. If I draw a vertical line here, it doesn't even go through relation, but if I go right here, boop, 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 it fails the vertical line test, okay? So that's another way to say it. Hopefully that helps. Remember, there's a quiz tomorrow. Good luck.